Welcome to the Potter's Roundtable, a monthly podcast where we share our passion for the ceramic arts and a collection of topics specific to potters. Remember to subscribe so you don't miss a single episode. Enjoy the show.
Okay, good morning everybody and welcome to another session of the Potter's Roundtable. At this point I'd like to mention that we've had pretty good success so far on reception to our presentations. So what we've decided to do is to collect all the presentations that we've done and put them in the sequence that you would have in, for instance, like a clay or a ceramics textbook. So each one of the presentations will be listed as a chapter, and then we hope to publish them in other forms in the future. Today's topic is, we're going to be starting off and doing these subjects in the order in which, pretty much following the order in which we would be making clay or making pottery. So we're going to start off with a discussion of clay. Today's topic is, what is clay? Well, clay, for a definition, clay is a naturally occurring mixture of very fine-grained minerals. And then as a definition of a mineral is a naturally occurring inorganic chemical compound. And the point is that minerals have very specific chemical compositions. They're not just weird collections of atoms or of elements. You can write a formula for a clay mineral, so they have very specific compositions. So naturally occurring clay, like the kind of clay you'd find in the ground, consists primarily of a mixture of several different kinds of clay minerals that we'll talk about, plus quartz, which is found all over the place. And this is an example of a piece of quartz. Quartz is a very common mineral, and this is an example of a large chunk. It's very durable and it's persistent in nature, and it's found as sort of an impurity in all kinds of rocks and sands and minerals. So this is probably quartz, only in a very fine-grained form. This is probably the major impurity that you find in clay. So you have clay minerals, which we'll talk about in a minute. You have quartz, and then you also have other impurities that occur naturally in the clay. Some of it might be organic material like pollen grains or dead vegetable material. And you also fairly commonly have sulfur minerals like iron pyrite or fool's gold is a fairly common impurity. The most noticeable characteristics, again talking about defining what clay is, the most noticeable characteristics of clay are really two. One is that when it's wet, it tends to be soft and it's plastic. That means it's malleable or it's moldable. And it's also slippery when it's wet. And all of these characteristics are features that we like and we use to our advantage. The other point is that when it dries, it shrinks and it very often cracks. The clay mineral, when I mentioned the clay minerals are a family of minerals that are formed naturally from other rocks, pre-existing rocks in nature. And they're either formed on the surface by weathering processes, or they're formed deep underground from hot solutions from volcanic sources. And they form from other rocks and other minerals. For example, granite is a fairly common original source rock for the formation of certain kinds of clay. The clay minerals are grouped together because they all have fairly similar properties. They're very fine-grained, which means that the individual particles of the clay, when you find them, are very tiny. Most of them, in fact, the individual particles are about the same size as your red blood cells, which, if you're into dimensions, is about 13 microns in size, 13 thousandths of an inch. They also have what's called a platy structure, which means that the individual particles kind of resemble decks of cards. This is a model that I made of sort of a typical structure of clay. And the individual particles represent these sort of bundles of layers or bundles of sheets of clay. And as you can see, each one of these bundles represents an individual clay particle, and they're more or less randomly arranged. They're in the mass or the form of wet clay. This platy structure, this flat structure, is actually due to the arrangement of the atoms within the clay, and that's because the atoms tend to be arranged in sheets or layers, so that internal arrangement of the atoms is reflected in the external form of the clay. And this platy structure is a really important property of clay because it's responsible for almost all of the properties of clay that we like as potters and also the ones we don't like as potters. It's responsible for the plasticity of the clay. Basically, water gets between the individual plates, or they're called platelets, the little particles, and it provides lubrication, and the particles slide over one another. That's the source of the plasticity in the clay. It also is responsible for the dried strength of the clay. The clay is fairly strong. It isn't crumbly like sand would be, for instance, when it dries. And that, again, is responsible for the platey structure. These plates overlap and sort of attach to one another and give the material some strength when it's dried. They also, the platiness is also responsible for some of the properties we don't like the shrinkage of the shrinkage of the clay when it dries and also when it's fired. And what happens is, one of the major changes is when the clay dries or when it's fired is the plates, the layers shrink closer together. They also shrink in size, but they shrink a lot in terms of the spacing between them. So the decks of cards sort of collapse. And related to that is also a lot of the cracking properties are related to the shrinkage that occurs during drying and firing. The group of clay minerals includes a number of minerals, but the three most common ones that we see are these three. So these are the three most common minerals, and these are actual mineral names. So these are not, some of these may be similar to the names that we see when we talk about a clay body. We talk about, for instance, kaolin clay. Kaolin clay is composed primarily of the mineral kaolinite. And as I mentioned before, you can actually write a formula for a mineral because it's a specific chemical compound. Just as an example, this is the chemical formula for kaolinite. Basically one molecule or one unit of aluminum oxide, 2 of silica, and 2 of water. We'll talk about this in a minute because this is a really important feature of clays. Illite is another kind of clay mineral, a little less common than kaolinite, but it still is fairly common in nature. And montmorillonite, this is what we know as bentonite. And this is another, we don't use it, you can't make anything out of montmorillonite, basically. It's used as an additive in clay bodies and also in glazes. These are the two main materials that are going to occur, types of clay that are going to occur in a clay body. And a definition, if you want a definition, sort of a broad definition of the clay minerals, they're layered hydrous aluminum silicates. Layered, which I already referred to, the fact that the physical structure is in the form of layers, and so are the sheets of atoms. They're hydrous, meaning they actually contain water in the structure of the material. This is called chemical water. This is not absorbed water, like they don't necessarily feel wet to the touch. This is water that's actually built into the structure. And this is important because it'll explain some of the behaviors we're going to talk about later. The word clay is actually used, when we use the term clay, in several different ways by different people that use it. For example, in earth science, clay doesn't necessarily refer to a particular material, just a particle size. So that in earth science, and particularly in soil science, when you talk about clay, all that means is particles of a particular very fine size. And the sizes, for instance, are like sand, and then a little finer is called silt, and then a little finer is called clay. Regardless of what that material actually is, it's called a clay or a clay-sized particle. Or in earth science, they also will refer to clay as meaning specifically the clay minerals. But in ceramics, we tend to use the word clay very loosely, referring to a lot of different things. We talk about it in terms of naturally occurring clay deposits, different types of clay that's found in the ground, such as ball clay, fire clay, kaolin. These are different ways that the clay forms and results in different deposits. We also use it for just meaning the wet material, the starting material that we use for making pottery. And we also we talk about bisqued clay or high-fired clay, which is, even though we use the term, both of those actually are no longer clay. Once the clay has been fired, it's actually a ceramic. It's no longer clay, but we still tend to refer to it as clay. So as potters, we tend to use the term clay rather loosely for in a lot of different meanings. The properties of clay that are really the main ones that are of interest to us as potters there are 3 of them. The first one is the interaction with water, and that refers to, for instance, the fact that clay gets soft and becomes plastic or deformable when it gets wet. It also provides lubrication when it gets wet, and it also we can dilute clay with a lot of water and actually produce what are called slips, which is just a mixture of water, like a slurry, a mixture of water and clay. And all of these are useful for us for the forming and the shaping of the clay, these properties. We also are very interested, because of our processing sequences, in the drying characteristics of the clay. What happens when the clay dries? That will, by the way, be the subject of our next presentation, the drying characteristics. And then finally, we're interested in the firing characteristic. What happens to clay when it fires? How can we take advantage of the properties? And what do we have to avoid when we fire clay? Clay actually has, the clay materials and the clay minerals actually have a lot of other industrial and commercial uses beside pottery. In fact, the majority of clay has nothing to do with pottery at all. It's used for other purposes. One of the principal uses of clay is for coating paper. This is probably the single largest use of fine white clay, such as kaolinite, because the clay, when it's coated on the paper, can change the color or the whiteness of the clay. It changes the paper. It changes the reflectivity of the paper, and it also provides a good printing surface. Most paper alone does not have a good enough printing surface to reproduce fine details. So by adding a fine layer of clay on top of it, you get a dense surface that will take print better than just the paper fibers alone. Clay is also used for absorbents for oil and other hazardous fluids, and we use it at home, even, for example, for cat litter. That's a form of dried clay. It's also used in what are termed drilling muds or drilling fluids, because when you mix clay with water, you get a very thick suspension of the clay in the water, which is good for suspending other particles. So it's used to pump down oil wells and lift the sand and the other drilling debris and remove it from the well. They're called drilling muds, and it literally is a slurry of clay and water. Clay is also used as a filler or a reinforcement in plastics. Molded plastics especially can be made a lot stronger by adding an internal reinforcement in the form of these little platelets, these little clay discs. And so it does two things. It actually strengthens the plastic, but it also reduces the cost because the clay is less expensive than the plastic. Clay is also used as catalysts to produce a variety of chemical products for gasoline, for example. Because the clay exists in these very tiny little particles, the area on the surface of the particles, there's a lot of it. The finer the particles, the more total surface area of the particles. And this is the exact characteristic you want for a catalyst. You want whatever the chemicals are to be exposed to the surface of this material. And they help bring about chemical reactions. So they're used for gasoline and other catalyst materials to produce chemical reactions. They're actually, in more common uses, they're used, for instance, in pencils. What are called quote-unquote graphite pencils or pencil leads are actually a mixture of graphite and clay. And the way they achieve the higher or the harder pencil numbers is by adding more clay and less graphite. And finally, they're used in medicines and cosmetics. You may have heard of kaopectate. Well, the KO refers to kaolinite. And they're also used in facial creams and as the basis for facial creams and makeups. Okay, so the starting material for pottery, now we're going to talk about getting back to pottery. The starting material for making pottery is generally not just plain clay or one of these naturally occurring kinds of clays that you dig out of the ground, but it's a mixture of materials called a clay body. And a definition of a clay body is a mixture of different kinds of clays plus other materials prepared for a specific purpose. And so, for example, you might formulate a clay body, a mixture of different raw materials that you're going to use for a particular forming method. For example, you might find out that certain proportions of clays and materials work better for extrusion than for throwing, or they definitely would work better, for example, for slip casting rather than slab work. So ideally, what you'd like to do is you'd like to formulate a clay body for a specific purpose, and therefore you can really refine the properties and optimize it for that particular use. Most commercial clay bodies are not made that way. They're made to be broadly used for a variety of techniques, so they work fairly well for a lot of techniques, but maybe not as well as they could if they were designed for just one technique in particular. Clay bodies can be developed for a particular firing temperature, and this we're already probably familiar with. You have cone 6 clay bodies and cone 10 clay bodies, and in order for them to perform the best at those two different temperatures, they need to be formulated differently. And you may even have materials that are formulated for different firing methods. For example, you might have a wood firing body that's formulated to respond to the flashing technique characteristics that you get, which you wouldn't need in an electric or a gas firing body. They also can be formulated to have specific handling properties. Like for a particular process, you might want the clay to be very plastic to the point where maybe it would not be suitable for hand building or it would not be suitable for throwing, but for this particular process, you might want that property, so you develop it for that. And then finally, it can be developed for specific final fired properties like color. you might want a particular color to the clay body once it's fired. Or you might want a particular texture to the clay body. You might want it to look coarse and sort of granular, or not. On the opposite end, you might want it to be very smooth and not be able to see any of the individual particles in the clay. All of that would depend on the raw materials that you use to combine to form the clay body. There are three general types of clay bodies that are used: earthenware, stoneware, and porcelain. And earthenware is generally, there are two forms of it. There's red earthenware or white, and then stoneware and porcelain. And then there are also other sort of, in more recent years, people have developed specialized clay bodies for particular uses, such as raku firing. So there are raku bodies. There's paper clay, where paper fibers are added to the clay to give the material extra strength and during the forming process, and also in the handling and the drying. And as I mentioned earlier, there are clay bodies now that are being produced specifically for wood firing because the ingredients respond particularly well to the flashing characteristics that you get out of a wood firing. There are clay bodies that are called oven or flameware that are very thermally shock resistant, so that if you wanted to produce cookware, that you could, for instance, you could set a pot on a stove and turn the heat on right away and not have to preheat it, or kind of analogous to Corningware, but only in a ceramic. And there are sort of specialized bodies made for that purpose. Bone china is another specialized clay body where it resembles porcelain. It's fired at a lower temperature, and it has this translucent, so it can be made very thin and has this nice sort of elegant translucent look to it. And then there are other types called Parian ware, for example, which is a low-fired porcelain that's used for a lot of sculptures and sculptures and figurines. And it has the look of porcelain, but it can be fired at a much lower temperature. Some of the general characteristics of these three different types of bodies. Earthenware is generally considered a low fire or a low temperature body. Low temperature still means 1800 degrees, give or take a few hundred degrees. And the point is, when you fire earthenware, it doesn't vitrify. The vitrification is the process where glass is actually formed in the body when it's fired because of partial melting in the body. True earthenware does not vitrify in that sense. The particles, when you heat it up, the particles bond together. It's called sintering, and the particles are adhere to each other, and the strength of the material increases. But when it's fired, there's still a lot of porosity in the body. The body has not gotten completely dense. It's still porous. It's hard. It's a lot harder and stronger than it was before it was fired, but it still is a relatively porous, soft body. Stoneware, on the other hand, is generally considered a high-fired body, and the idea is when it's fired, if it's formulated properly, the body gets almost completely dense to maybe completely dense. There are no holes in it. It's not porous any longer. And when it's fired, it also does undergo what's called vitrification, meaning that the ingredients in the clay body combine, and there's actually partial melting within the clay body that results in the formation of glass. And the formation of glass actually helps the material get denser while it's fired, and also adds to the strength and the density when it's after it's fired. And the last kind, porcelain, is related to stoneware. Only it's a high-fired type of body, but it gets even more glassy than stoneware does. And porcelain generally has a characteristic of it's usually a uniform, fairly white texture. Stoneware literally can resemble the surface of a stone, meaning you can see individual grains and contrast between the individual particles in it. Porcelain is revered for the fact that you don't see that. You see pretty much a smooth, uniform, creamy, or a true white body without seeing the individual particles. But a lot more glass is formed in the porcelain during firing, which is responsible for the fact that it's translucent. Is that when porcelain is thin, it can be translucent, and that's because of the greater amount of glass that's actually present in the body. When you're in clay bodies in general, you can talk about how you formulate a clay body, and there are three categories or three types of components that are used in a clay body. Clays, which we'll talk about in a minute, fluxes, and silica. The clay we've talked about, we'll talk about those a little bit more in a minute, about the different kinds of natural clay that you can use to formulate a clay body. A flux, by definition, is a material that you add to something else to help it melt at a lower temperature. And the reason why we do this for clay bodies is most of the naturally occurring clays, at least the high fire clays, if you were to fire them to the temperatures that we have available to us in our pottery kilns, they wouldn't get very hard and very dense. They wouldn't be very strong. So we add something to them to help them partially melt that helps them get denser and stronger when they're fired. And those additives are the fluxes. This is some of the material that helps them get denser, and it helps them fire within the range that we can reach in our pottery kilns. And silica is just that, is silica. So the three types of components, the three categories of components that you would have in any clay body would be clays. And you notice it's plural because in general, when you're formulating a clay body, you don't use just one type of clay. You want a mixture of clay. One of the really important properties to obtain or to achieve when you're making a clay body is to have a broad range of the size of the particles that make up the clay body. That makes the clay body most usable and most flexible for different applications. If the particles are all fairly coarse, then, for instance, the clay body might not be useful for throwing. Or if the particles are too fine and the clay is too plastic, then it might not have enough body to make large forms out of it. They might collapse under their own weight. So ideally, you want a broad range of the sizes of the individual clay particles. And the best way to achieve that is really with a mixture of different kinds of clays that have these different sized particles. So we'll talk about that in a minute. And then the fluxes I mentioned, this is the material or materials that you add to help the clay get dense when it gets fired. It's for the firing characteristics. And silica, this is the same silica, the quartz that I referred to earlier, that occurs as a natural impurity in the clay, only in this case we're going to add more of it, because we want to add more silica to the clay body so that it will have the chance to form glass that I mentioned when it's fired. So the fluxes and the silica will form more glass when we fire the clay body. And again, the formula is SiO2, and the common form that we find is what I mentioned earlier, is the mineral quartz, the same one that occurs as an impurity in the clay. Ideally, we would like it not to be present in the clay, and we'd like to add it ourselves so we know how much is in there, but we can't avoid that. It naturally occurs in the clay. Okay, there are different kinds of naturally occurring clays that occur in deposits in the ground, depending on how they're formed. And these clays from these different deposits have different properties that we can take advantage of for formulating a clay body.
If you would like more information about our membership studio, classes, events, and multimedia productions at Washington Street Studios, visit our website at www.hfclay.com.
So there are several different kinds of naturally occurring clay deposit, and the properties of the clay in those deposits really depend on what the original source of the clay was, what type of rock it was formed from, and the processes that it underwent to change into clay. And these are the main types. First kind is called kaolin clay, and as kaolin clay is composed primarily of the mineral that we talked about earlier, kaolinite. So the kaolin is the type of clay, kaolinite is the clay mineral. And kaolin clay is generally fairly fine-grained clay, and it also tends to be very pure. This is one of the clays, if we want a white clay body, we generally would want to use some kind of kaolin clay. There are differences in some cases in terms of minor impurities, but it's generally a white clay. It starts out white and it stays white and becomes a white clay body. Generally by itself, it's a high-fired clay. By itself, it would not get very dense if you fired it at our normal temperatures. We'd have to add a flux. Two examples of it are EPK. EPK stands for Edgar Plastic Kaolin. That's a kind of clay mined in Florida in the United States. And Graulig is a kind of kaolin that's mined in England. Another name for kaolin is China clay. That's the other name for it. Yeah. But so if you see a recipe for either a glaze recipe, because this is also fairly commonly used in glazes, a glaze recipe or a clay body that calls for China clay, that's the same as kaolin. Okay. Another kind of naturally occurring clay deposit is called stoneware. Stoneware is also a high-firing clay. It's not as pure as kaolin. It's not going to fire a white. Typically, it's going to fire an off-white or a cream color, but it still is a high-fired clay. But the particles are not quite as fine as kaolin, and it may have a slight texture to it when it's fired. It may not be just purely white or purely cream. It may have a little bit of texture to it. One example of at least an American USA type is called Gold Art clay. That's just a brand name for a particular kind of stoneware clay. Fire clay is another characteristic. This is probably the coarsest kind of naturally occurring deposit that we can find, meaning that the individual clay particles tend to be fairly large. It's fairly granular. It's also very variable. Because of the way fire clay forms, it can be very variable from one deposit to another, or even from within the same kind of deposit. So but it's probably the coarsest clay of all the kind of naturally occurring deposits. A fairly common example is called Hawthorne Bond. That's a brand name like Kleenex or Scotch tape. It's a brand name for it. Okay, so that's the fire clay. Also, the other thing I wanted to mention was fire clay is also, this is what's used, because it's fairly inexpensive, it is variable, this is what's used to make most refractory bricks. Most bricks, kiln bricks, dense fire bricks, and even some insulating fire bricks are made out of fire clay. It doesn't have to be extremely pure, it doesn't have to be extremely fine to make the bricks out of it, and actually it works very well just to make bricks out of it. Another kind of clay is called ball clay. This is also a high-fired clay. But one of the differences here, and you'll see as we go along, this is an extremely fine particle size. So whereas fire clay is found naturally in nature with kind of a coarse, gritty texture to it, ball clay is extremely fine grained, which means that also when it gets wet, it's extremely plastic and it's extremely slippery. So for instance, you would not use ball clay alone for the clay body. The clay body, you have to mix it with something else. This can be used to add plasticity to the clay body. So you might add ball clay, for instance, to fire clay or to fire clay plus stoneware to make the body more plastic and to make it finer. But because it's fine grained, it also and absorbs a lot of water, it's going to shrink a lot when it dries. So you want to avoid, for instance, having too much ball clay in a clay body. A fairly common example is OM4, which stands for Old Mine Number 4, a brand name for a type of ball clay. Another kind of naturally occurring deposit is common clay. This is the red brick clay that you see around that's used. It's also called earthenware. It's also called brick clay. It's also called terracotta. And in contrast to all of these, this is a low-firing clay. This is a naturally occurring clay that has a lot of fluxes in it as it's formed in nature, and so it tends to densify and get hard at a very low firing temperature. And this is used literally for things like it's used for ceramics, for earthenware ceramics, low-fire ceramics, but it's also used for bricks and other industrial products, pipes and that sort of thing. The last one I want to mention is bentonite. Bentonite, this is the naturally occurring form of the mineral that I mentioned earlier, montmorillonite. Bentonite is sort of the rock name or the deposit name, but the mineral that it's composed primarily of is bentonite. And bentonite is probably the finest particle size of all these different kind of clay materials, but it's so fine that you can't make anything out of it. Bentonite is only used as an additive to certain clay bodies to make them a little more plastic, or it's used as a processing aid for glazes, which we'll be talking about in one of our future discussions when we talk about glazes. So it is fairly high firing clay, but it's not used as a major ingredient. Most of the clay bodies a high firing clay body would be made out of these, and a low firing clay body would be primarily these, and this would be an additive that would be used to the other clay bodies. Okay, so those are the kind of naturally occurring clay deposits. So we would select, based on the different properties of these that we know about, we would select from these and make combinations to form the clay body. The next category that I mentioned of ingredients were the fluxes. And the fluxes, again, this is a material or materials that we add to the clays to help them bond together and partially melt when we fire them. And these consist of the following materials. So these are 4 examples of categories of different kinds of fluxes that can be used in clay bodies. The first one, and one of the major ones, are feldspars. Feldspar is a type of mineral, and there are two different types of feldspar. Feldspars sodium or potassium aluminum silicates. So there are sodium feldspars, that's the symbol for sodium, and there are potassium feldspars. And they have slightly different properties. So we'll talk about you'll hear reference to a soda feldspar or a potash or potassium feldspar, and they have slightly different characteristics. That's one of the principal materials that's used as a flux. Another fairly related material, this is a mineral. Nepheline syenite is actually a rock. It's a powdered rock that contains feldspars as well as other materials. So it contains some of these as well as other materials. And it melts, has slightly different melting characteristics than these. So there are certain times when you might select to use nepheline syenite instead of one of the feldspars. Powdered glass, which are also called frits. Frit is a powdered glass of a known characteristic. Powdered glass can actually be used. And this was fairly common in a lot of southern United States pottery, sort of like country or folk pottery, was in addition to the local clays, they'd add powdered glass. And it might just be powdered glass from crushed bottles, for example, as well as using commercial frits. And finally, talc can also be used. Talc is used primarily as a flux in white earthenware. Earthenware bodies that occur in nature are primarily contaminated with a lot of iron, so when they fire red or tan or brown. In order to produce a white earthenware, that is a low-firing white body, it's basically a synthetic body. It doesn't occur naturally in nature. So you would take a white clay, a white firing clay, such as a kaolin, and then you'd have to add a flux to it that would make it melt at a low temperature. And talc is a mineral that can be used to make a low-temperature flux. So talc would be used most likely in earthenware bodies, low-fire white earthenware bodies. Okay, so we would choose one or more of these to be the source of the flux for the body. And the third ingredient that we talked about is silica. And so in order to form enough glass for a lot of, especially the high-fired batteries, we have to add additional silica beside what's present in some of these and beside what's coming along as contamination in the clay. So we would add additional silica. Then the other thing is, those are the three main components for a clay body. In addition to that, we might want to add other particular materials to refine the characteristics. Like we might want to add what's called grog, which is grog is basically pre-fired clay. It's granular, almost as like sand, only instead of being sand, it's pre-fired and crushed ceramic. So it could be made of like fire clay. There's a form of grog made from kaolin called malachite, and the advantage of that is it's basically pre-fired kaolin so that it's white instead of being colored. And in some cases, actually, you can buy commercial grog, and it's just made from crushed or recycled fire bricks. And what the grog is doing is it adds what's called tooth or body to the clay body. By adding these coarse particles, it stiffens the clay, basically. It also helps some of the drying characteristics. It reduces some of the shrinkage of the clay when it's fired and dried, and it also adds strength to the clay. So you might decide for a particular application, for example, for sculpture clay, where you're not worried about the extreme smoothness of the clay. It's very likely that you might have grog or sand or some coarser addition added to the clay to give it strength and stiffness. Okay, so the last part of this I want to talk about briefly is just the approach to how you actually develop a clay body, just touching a little bit more on what we've already said. So if you were going to start off from scratch and develop your own clay body, and by the way, this is something that's fairly common among professional potters, is that once a potter has worked out or selected a particular firing method and a particular type of work that they want to make, very often they'll find that they can do a lot better making their own clay body for their particular use and their own particular characteristics rather than a commercial body. So this is one of the reasons why a lot of production potters and a lot of commercial professional artists, they end up making their own body because it can be tailored to have the exact characteristics that they want for their style or their processing, and it can actually work better than some of the commercial bodies. So the first step would be to prepare a blend of different kind of clays. And as I mentioned earlier, one of the things you're trying to achieve when you're formulating a clay body is to have a broad range of particle sizes. By particles, I mean the tiny little individual particles that are in the clay. Ideally, you'd like a broad range in sizes. One of the reasons for this is when the particles pack together, You want them to fill the space efficiently. For example, if I would take a bunch of basketballs and bring them close together, I could pack them close together, but there would still be a lot of spaces between the basketballs that the basketballs couldn't fill. So what I could do then would be add baseballs to that mixture and have baseballs and basketballs. And between the basketballs, I could tuck some baseballs. Well, between the baseballs, there are still going to be spaces. So then I could add some marbles to fit in the spaces between the baseballs, which are between the basketballs. That's the principle of what you'd like to do when you formulate a clay body. You'd like to have a range of sizes, but you'd like to have them so that when they pack together, they can fill the space completely without leaving any holes or space. And that way the clay is much more likely to get dense and strong when it's fired and have much better handling properties. So the first thing we would do is we would do some experiments, and we'd test some different mixtures of clay bodies, and we'd measure properties such as the plasticity of the clay. We'd take a mixture of the dried clay powders, wet it, and then look at the mixture and test it to see how plastic it is. Does it suit our particular needs for whatever our process it is? We'd like to measure, for example, the water absorption, because if it's going to absorb a lot of water, then when it dries, chances are it's going to have to give up that water. It might shrink a lot. So we wouldn't want to formulate a clay body, for example, that absorbs a huge amount of water when you make the clay body, because the water's going to come out. Chances are the clay body would shrink a lot, which means that it might be subject to cracking. So we'd have to keep a track of that. We'd also want to check on things like the shrinkage. A very common procedure when you're formulating a clay body is to make up little shrinkage test bars, and you'd make up your clay body up, or in this case just your mixture of clays, and you'd make these little bars, make them a certain length, and then let them dry, and then measure them again and measure the shrinkage. And then you'd fire them and measure the shrinkage again. Because again, you wouldn't want a mixture of clays that's going to shrink a very large amount when it dries or when it's fired, because that's liable to lead to cracking and warping during the drying, or cracking and warping during the firing. You have to control the shrinkage. And you can control that with the mixture of particle sizes. So you want some shrinkage because you have to have some fine particles, but you don't want too much shrinkage. So then once you've got your clay mixture, then you set up what's called a triaxial blend. So once you've developed your clay mixture that seems to have the properties that you want, now you're going to take that clay mixture and combine it with the other two categories of components that go into a clay body. And you're going to perform a series of tests that are what are called the triaxial blend. What this means is, this is a diagram that shows if I take these three components, clays and flux and silica, and I make this kind of a diagram, then every point inside this triangle represents every possible combination of different amounts of these three ingredients. So for example, halfway along this line right here, just this outside, just between there and the silica, means that this point right here represents 50% clay and 50% silica. And this point down here represents 50% flux and 50% silica. And this one here is 50% flux and 50% clay. And when I go inside the triangle, like this point right here, that's 1/3 clay, 1/3 silica, and 1/3 flux. So by using this diagram, I can plot all the different possible combinations of these three ingredients. So that's what I want to do. So I might take my mixture of clays that I have, and I'll pick a flux. Let's say I'll take a soda feldspar and then some powdered silica, and I'll make maybe 10 different combinations. I could divide this up so I could have hundreds of combinations here, but I might maybe do 10 different combinations of those three, and I'll test them to see what works the best as a clay body. And I'll do the same thing I did before. I'll do shrinkage tests, I'll measure the plasticity, I'll do firing tests, I'll look at the color, I'll look at the strength of the firing. And this is a way of screening and finding out what's the best possible combination for my particular application of the clays and the flux and the silica. And it's fairly common to have to do this more than once. I might do it once, and then I find out, well, there's a particular area here which seems to be working better than certain areas, and I might refine it and do a little more testing in that area to nail it down even more specifically, to get a specific composition. Anyway, this is the approach. This is what I would do experimentally to produce a clay body. And what I'm going to do, I'll just put up a few basic clay body recipes on the board, just so you can see an example of how this has worked out.
Thanks for watching this video. Please like, subscribe, and share it with your friends.
Okay, so here are two very simple recipes, examples of recipes of formulas for a clay body. A basic stoneware recipe, and there are thousands of these out there, but this is just one, would be fire clay 60, this is all based on weight percent. Fire clay 60% and ball clay 20%. So this is in this case, this is our clay mixture. Fire clay, as I mentioned, is a very coarse kind of clay, which would not be very plastic by itself. So it would not necessarily be good. It might be good for sculpture, but with just the fire clay, this wouldn't probably be very good for throwing or for something where you need more of the plasticity. So in this case, we've added some ball clay to it to make it more plastic, but not too much, because ball clay is going to shrink and crack a lot when it dries. So we want enough to give it plasticity, but not so much that the clay is going to maybe crack when it dries. And then feldspar 10% and silica 10%. And both of these formulas, the stone and porcelain, we're talking about firing at cone 6 or higher. And then a basic porcelain recipe. Now, stoneware is going to be colored. It's going to be buff colored or tan or something. It's not going to be white. Porcelain, we want it to be white. So we're using now China clay, which is again a very fine clay, but not particularly plastic again. So I have to add some ball clay to it to make it increase the plasticity a little bit. The one thing this is going to do, because ball clay is not quite as pure in most cases as the China clay, it's going to decrease the whiteness slightly. It might make the porcelain look slightly off-white or gray or cream colored, very slightly, depending on the firing method. So this is where, for example, you might want to pick the ball clay you use very carefully to get a fairly pure ball clay so you don't contaminate the China clay. But this represents, in our triaxial diagram before, this represents our clay mixture. And again, now we add a feldspar and we add silica. So those are two fairly basic, sort of, simple recipes for two examples of two different kind of clay bodies. So I hope this has been useful. This discussion has been useful to you. If you'd like to support our outreach efforts, and this is one of these programs are one of our outreach efforts to the community, you can go to patreon.com and search for the Potter's Roundtable. We'd appreciate any support you'd be willing to contribute to us. The next two topics in the series that we're going to be doing will be the drying characteristics of clay, and the one after that we'll be talking about bisque firing and the process of what happens to clay when you process it. So thank you very much.
The Potter's Roundtable is brought to you by Washington Street Studios and our patrons. If you enjoy the show, please subscribe, give us a 5-star review, and tell your friends. If you want to learn more about Washington Street Studios and shared studio memberships, please visit our website at www.hfclay.com. Thank you, and we'll see you again next time on the Potter's Roundtable.